Hello there, it's Michael here at the Village Optician, and today I'm going to be answering the question, how does the eye see? Okay, now we'll look at this purely and simply from the sort of anatomy of the eyeball itself, how each part of the eye kind of helps the eye to see, how we get the light focused onto the back of the eye, things like that. Because the strange thing about all this is that you actually see with your brain. When you kind of think about that, it's sort of, you can think, oh yeah, makes sense actually. It's your brain that sees, your eye catches the light and sends that message off to your brain, and your brain pieces it all together and makes the picture. Okay, so we'll start off at the beginning. We'll kind of work through it as if we are following the light going into the eye. So first of all, we have the very small transparent window right at the front of the eye there. Now that is called the cornea. And you can see the pupil and the iris through the cornea, so it has to be transparent, otherwise the light can't get in. So that's the first part of the eye. Now that is curved, and that will bend the light going into the eye. That's the first surface that's going to bend the light going into the eye, trying to get the light focused into the back of the eye so we'll get a nice sharp image. Okay, now the next thing to talk about then is the iris, which is the coloured part of your eye, and the pupil, which is that little black hole in the iris. Now the pupil is literally just a hole. It's a hole in the iris. Okay, the iris is a muscle that gets bigger and smaller, and hence your pupil gets bigger and smaller in certain conditions. So the iris is the coloured bit, the pupil is the hole. Now the reason that the pupil is black is because no light comes out of your eye. Okay, things only have a colour because light comes, a certain wavelength of light comes off those things. Now, the reason we get red eye in some photographs if there's a really bright flash is because the back of the eye, the inside of the eye itself, is actually red. And if you throw so much light into the eye, you can get a reflection off the back of the eye and you get a red pupil. So you're actually seeing the back of your eye when you see red eye. Okay, so the light will come in through the pupil. Now, as I said, the iris is just a muscle that gets bigger and smaller depending on the light. So if it's very dark and there's not enough light around, the iris will get bigger, will move out the way, and therefore your pupil gets bigger to let more light into the eye. If it's very, very bright, what will happen is your pupil will shut down, it will get smaller, so the iris muscle will actually contract to make that smaller, so we get less light in the eye if there's too much. Okay, so the next thing that happens is behind the pupil, so inside your eye, behind the pupil is the lens. Now, the lens is very clever because the lens is there to try to help us to see things at different distances. Okay, so the lens will kind of change its shape like this to kind of try to focus that light from coming at us from different distances onto the back of the eye. Because it's all about getting that light into the back of the eye and getting it onto the retina. So as we move through the eye, the very back of your eye is called the retina. Now that is the bit where you get all the photoreceptor cells. Now what a photoreceptor is, it's basically a little cell that's going to catch the light. Okay, it's going to catch the light. It's going to change that light into an electrical impulse. And so the retina is made up of these photoreceptor cells and nerves essentially. Okay, so it's going to catch the light in these photoreceptors. It's going to change that into like a little electrical impulse and send it off down the nerves and down your optic nerve and into your brain. It's going to come all the way around, and it's actually the back of your head there that works it all out. Okay, so that is the visual cortex. That's what you see with. Okay, so that's kind of how it works. Now we want that light to get to the retina. We want that light to get nicely onto the retina at the very back of your eye. We need a nice sharp image, a nice sharp focus. So all of the different curved parts in the eye, like the cornea, then you've got the lens, all that kind of stuff. So everything comes, the light comes in through the eye to the back of the eye to the retina. It wants to try to get it focused on the retina just nicely, and that will give you a nice sharp image, and therefore you'll have good vision. If the image falling on the retina isn't sharp, for example if you're short-sighted, or if you're long-sighted, or if you have astigmatism, the image isn't quite getting onto the retina nice and, a nice sharp image on, a nice sharp focus on the retina, that's when your vision will be blurred. Okay, so if you've not got a sharp, nice sharp point on the retina, it's just going to be a blur. Okay, so that's kind of how we see with our eyes. As I say, we don't actually see with our eyes. They catch the light. It's a very clever tool for catching the light, converting that light into an electrical message that our brain then works out and kind of pieces it all together, and we can see. It's amazing, really. Won't go too deep into that, because then we can talk about, do we all see things the same? And that's a whole another conversation. We could be here all day. So anyway, that's kind of how the eye sort of works. That's the different parts of the eye, how the light passes through the eye, how they all work together. It's very important that they all work together to kind of get that focus to where it needs to be. Okay, anyway, so look out for some more videos. We'll be explaining a little bit more about different conditions with the eyes and how we can help. Okay, cheers, bye.